Audio Jungle.
Hadoop fundamentals. Okay, so in this session, I'll define what is big data and what are different factors involved when moving to the scale of big data. So we'll review few case studies of recent big data projects. So I'll show you how actually the big data process works. We look at big data architectures and its technology landscape. So today, a few years back, if I had data, I had knowledge. But today, data is no longer an asset. Data is revenue. So I'll tell you how big data is transforming business. Okay. So you all understand we have a lot of digital data over the internet, right? So if I ask you a question, in what units do you think we express the size of world's digital information today? So there are a lot of units like starting from bits, we have bytes, and then we have kilobytes, we have megabytes, gigabytes, and then comes terabytes, petabytes, exabytes, zettabyte, and yottabyte. So for those of you who are not familiar with what these units are, terabytes is 1024 GB, petabyte is 1024 TB, and so on. Okay, so let me explain. We have not yet reached the zettabyte scale. Okay, back in 2013, data was 4.4 zettabytes. In 2015 February, data is 5.8 zettabytes. Okay, and this is expected to reach around 444 zettabytes by 2020. Okay, so you can see how the data is growing. It's growing fast. It's growing in size, and it's growing constantly by a factor of 55. So if I ask you how many DVDs you require to accommodate 1 zettabyte of data, okay, so 1 zettabyte is 1 trillion gigabytes. So a traditional DVD can hold say maximum of 4 GB of data. So you require close to 250 billion DVDs to just store 1 zettabyte of data. So what if I ask you to process that 1 zettabyte of data that you store in form of DVDs, right? So that would be a very difficult task, because to process any chunk of data, you should have all the data stored at one place, right? So all the data has to be moved to a place where you can process it, apply your logic over it, and then write the results back to the disk again. So this is where the world is facing a lot of problems. So defining big data is very important, because the first question anyone would ask you is, what is big data? When you say I've attended big data demo session, or I'm going to a big data group training. So if you don't understand big data, then there's no point in trying and solving big data problems. Okay. So there are a couple of definitions. One definition from the McKinsey Global Institute, and one other definition from Wikipedia. So you don't have to worry about these definitions. Typically, like, the term big data itself is a very subjective term. So there is no standard definition for this term big data. But most people consider, if they have a bigger data set, say of scale terabytes or petabytes or more, so that is what they feel is big data. And this term big data is relative. Okay, so my machine has a storage capacity of 2 terabytes. So if I'm given a 1 terabyte file, if I'm asked to process it, I can very well store it on my machine and then process it, apply my logic, write the results back to the disk, right? So 1 TB is not big data for me. But those of you, for example, if you have a 500 GB storage, then 1 TB would definitely be big data for you, because data which cannot be comfortably processed on a single machine, so that is what we can call as big data. So this is a very high level definition to start with. So whatever technology we talk about, whatever tool we bring in, what is the end result we are looking at? So the companies, they are not looking at how do I build fame by saying like I'm applying big data architecture. They're not looking at fame. They're not looking at like good name in the industry. But the end result, everyone like target is revenue. How do I generate revenue, right? So look at big data from the business perspective, it can be defined like something like this. It's all about right time business insights and taking decisions at extreme scale. So how do you time your business insights and take decisions at extreme scale? This phrase extreme scale is very, very important. So extreme scale here refers to how do you scale your infrastructure at will based on the amount of data that is coming into your servers ready to be processed. So there are two ways of scaling infrastructure. Vertical scaling, which is also called as scaling deep, and the other way of scaling your infrastructure is scaling horizontal. It's also called scaling wide. So when you add additional storage space to a single machine, that is called vertical scaling. My laptop has 2 terabyte storage. If I was given a 4 terabyte file and if I'm asked to process it, the best way I can do it is add 2 more terabyte storage to my laptop, make it 4 TB, store the 4 TB file, apply the logic and process it, right? That is vertical scaling. But what if I'm asked to process a 10 terabyte file on my 2 terabyte laptop? I cannot scale my infrastructure vertically beyond a certain limit because there are architectural limitations. So that is when you have to scale your infrastructure horizontally. So when we talk about horizontal scaling, if I bring 4 more laptops, each having 2 terabyte storage, connect all the 5 laptops together, form a 10 TB distributed storage. So that is called horizontal scaling. So adding additional nodes or additional machines into your cluster is called horizontal scaling. So a quick question here, which of these can be considered to be big data? We have order details for the purchase at store, all orders across hundreds of branches nationwide, information about a person's stock portfolio, or all stock transactions made on the NYSE during the year. So I'll answer this, you can try and guess yourself. In case of A and C, if you observe, that is a very small chunk of data. We can very well handle this in a relational database. But in case of B and D, that is where the data itself is huge and it's growing complex and wide. So that is where our relational databases, they really start struggling. So I'll tell you why RDB must start struggling to handle data like in case of B and D. Looking at sources of data, you understand data comes from a lot of sources. So most people today have smartphones, and you know what a smartphone can do. It can do a lot of smart things. So forget about a smartphone. Think about a normal mobile phone, with a very basic mobile phone. So whenever you switch on your mobile phone, it starts getting signal reception from a close by tower. So when you're traveling from one place to another, right, the signal reception will switch from one tower to a different tower. So your service providers, they log all this information, using which they find out dead spots in the coverage. So if they can identify a dead spot, they can install an additional tower over there, thereby increase the coverage and then the market. They can also find out which is the busiest tower or whether a particular tower needs increased capacity or not. So this is one use case, the basic use case in the telecom industry. And e-commerce is one area where big data is being applied a lot. Whenever you visit a website like Amazon, eBay, or Netflix, right? Earlier, these e-commerce industries, like if you have huge money, you can invest and build an e-commerce portal, set up your products, and wait for the customers. But today, it doesn't work that way. You have to target your people. You have to target your customers. So whatever you do there will be logged, like what pages you viewed, what products you looked at, how long you spent on each page, what web browser you're using, and also what sort of computer you're connected to. So they store a lot of out-of-box data today. Earlier, these companies, they were only storing transactional data, and all the analytics were revolving around the transactional data sets. But today, a company like Amazon has improved its market by 40% just by making use of product recommendations and product reviews. and how frequently you write a review or recommend a product when you purchase it online. So one use case from the airline industry. So if you take a twin engine Boeing 737 aircraft, every engine is capable of generating close to 20 terabytes of data every 1 hour. So when I say an aircraft engine is generating this much huge information, it is essentially a sensor data. Okay. So if you take an average flight journey, say you're traveling from New York to Los Angeles, which is 6 hours. So in 1 year, all the commercial flights across the United States alone would generate 2.5 billion terabytes of data. So suppose if I give this project to you, right, if something goes wrong, if some catastrophe has happened, then you will have to take this data, identify which portion of data you're interested in, pull that data out, do the analytics, right? Or otherwise, even if something doesn't go wrong, you can still analyze this data to find out the trends, right? To know which carriers are doing best, which carriers are delayed carriers, which carriers are most popular carriers and all, right? So how do you go by when I give you 2.5 billion terabytes of data, right? So there is no question of processing this data and performing analytics unless you store this data first, right? So what are the two important things we need to have is we should have a storage capacity, huge storage capacity, and then huge processing capabilities. That is what we're looking at today. So there are a lot of other sources of data, like we have hours and hours of videos on YouTube. We have a lot of connections on LinkedIn. Facebook has a lot of status updates, comments, likes, whatever. Facebook, interestingly, it is one of the biggest generator of data and also one of the biggest solution provider for big data problems. So all your search engines like Google, Yahoo, Bing, all the email clients, all the social networks, they generate huge amounts of data today. So looking at this, a lot happens today in 1 minute over the internet. Lot of feeds, lot of status updates, lot of instant messages, lot of Google searches, emails. Close to 2,000 terabytes of data is created every minute over the internet. So what if I was talking about tweets, status updates, Facebook comments and likes few years back, people would have thought like what this guy is talking, like this kind of child's play is of no use for me. But today a lot of business revolve around these tweets, status updates. They're targeting their customers, making use of these things. So why are we generating data? What are the drivers behind big data? So every business, they want to explore their past business performance and they tend to gain insight and drive their business plan, right? So that is why data is required. Data is required to take appropriate action. So typically, all historical data sets were limited to either transactional data sets, surveys or sentiments or click logs. So these data sets were also huge, but they were often predictable and the analytics were often manageable. But today we have Internet of Things. We have multiple devices like mobile phones, tablets, GPS, RFID tags, etc. So we get streams of data from each of these devices, and adding to this, there is a lot of consumer-driven content on the internet, right? Like from social networks and social collaborations. We have online marketing, detailed click tracking, advertisements. So all this data coming from different sources is actually exceeding our previous analytic capabilities. So that is the reason why we are looking at new strategy to accommodate these new requirements. So there is always this question, is big data a hype or a game changer? Right? People argue, some people say it's hype, some people say no, it's a game changer. So these examples one can easily make out big data is huge data, right? But the size of data is just one side of the coin. Only 10% of data that we have in today's world is structured, and you understand where the structured data is stored. It goes into relational databases, structured stores. But the rest of the data is unstructured, either unstructured data or semi-structured data.